Welcome to This Explainer. We're jumping right into the delicate and honestly often completely invisible balance between our environment and our health. We're going to explore how the world around us can make us profoundly sick, but more importantly, how humanity and nature itself are fighting back. Is your home making you sick? Look, when we think of environmental hazards, our minds usually go straight to those massive, distant smokestacks billowing dark clouds. But today, we're starting right at home, looking at the unseen threats lurking in your own backyard and maybe even sitting right now in your kitchen. Here's our roadmap for today's explainer. We're going to cover the invisible chemical threats, the price of industry, the grassroots movements that saved forests, and finally, nature's warning systems. Section 1. The invisible chemical threats. What is actually lurking in your backyard? Think about the chemical cocktails we're exposed to every single day. Take lead, for example. Our bodies have absolutely zero need for it, but for decades, it was smeared all over our window frames and paint. Just opening and closing a window creates this fine, invisible toxic dust. And because lead actually has a slightly sweet taste, wild right, kids would ingest it, leading to devastating irreversible damage to their developing nervous systems. Then, think about your pantry. The food industry absolutely loves trans fats because adding hydrogen to vegetable oils stops it from going bad. Great for shelf life, terrible for us. Our bodies just can't break it down, which directly drives up heart disease and cancer risks. And water? A little fluoride is normal, but highly fluoridated water doesn't just sting your teeth, it heavily calcifies joints over time, leading to severe spinal issues and a painful condition called knock-knee syndrome. And here's the thing about these invisible threats. They don't just stay put. They travel and they multiply. Take DDT. We used to spray this pesticide heavily on marshes to wipe out mosquitoes. But since it doesn't easily break down, it triggers this terrifying chain reaction called biomagnification. It goes from the water to microscopic organisms to small fish to bigger fish and finally up to predatory birds. At every single step, the toxin gets more and more concentrated. By the time it hits apex predators like the osprey or the bald eagle, it severely disrupts their hormones. The female birds can't produce enough calcium, meaning their eggs are so incredibly fragile that the mothers literally crush them just by trying to incubate them. We almost lost entire populations of these magnificent birds because of it. Pollution is the ultimate hitchhiker. Back during the days of atmospheric nuclear testing, a radioactive isotope called iodine-131 got blown into the wind and settled all over pasture grass. Cows ate the grass, the isotope concentrated in their milk, and when kids drank that milk, their growing bodies pulled that iodine-131 straight into their thyroid glands, causing severe radiation damage and cancer. Actually, this is exactly why safe, non-radioactive iodine pills are handed out during nuclear emergencies. If you flood the thyroid with safe iodine first, there's no room for the radioactive stuff to get absorbed. Pretty ingenious workaround, really. All right, Section 2. The price of industry. Let's look at historical disasters and occupational hazards. When we scale up from our backyards to massive industrial hubs, the human toll gets devastating. In mid-century Japan, 3 localized tragedies perfectly illustrate the lethal cost of unchecked progress. First, you have Minamata disease. For over 30 years, the Chipko Corporation was quietly dumping methyl mercury right into a local bay. That heavy metal poisoned the fish and then poisoned the thousands of locals who ate them, causing this horrifying neurological symptom. Around that same time, massive petroleum burning in Mie Prefecture pumped out so much sulfur oxide it caused Yokkaichi asthma, severe chronic lung issues. And maybe the most heartbreaking one happened in Toyama Prefecture. Mass cadmium poisoning from mining literally leached the calcium right out of people's bones. They became so brittle that residents would fracture bones just by coughing. They literally named the disease itai itai, which translates from Japanese directly to it hurts, it hurts. Now, you might think of rural farming towns as these pristine, untouched places, but industry exacts a heavy price there too. Modern farming uses a massive amount of nitrogen-based fertilizers. When it rains, those excess nitrates wash deep into the soil and contaminate the local drinking water. If that nitrate-rich water gets mixed into baby formula, it triggers a reaction inside the infant's digestive system that drastically drops their blood's ability to carry oxygen. The babies literally turn a bluish color from oxygen starvation, a fatal condition known as blue baby syndrome. And of course, this kind of persistent pollution follows us right to work. For generations, coal miners have faced pneumoconiosis, black lung, where heavy coal dust permanently hardens inside their lungs. Construction workers battle asbestosis, from jagged microscopic fibers scarring their respiratory systems, while silicosis suffocates those working around sandblasting. Then there's emphysema, where sensitive lung tissue just breaks down from chronic exposure to harsh air pollution or smoke. But hey, what if you just work in a nice modern office building? Well, you might be dealing with sick building syndrome. To make office buildings energy efficient, they are sealed up incredibly tight. If the HVAC system has flaws, it traps this dangerous indoor cocktail of mold, CO2, and volatile organic compounds off-gassing from carpets and paint. So, ironically, the air quality inside your cubicle can be significantly more toxic than the smog out on the street. Moving on to Section 3, Movements that Saved Forests. Let's talk about the incredible power of grassroots resistance. So, facing all this relentless environmental degradation, how have regular people managed to fight back? It's an incredibly emotional history. Long before environmentalism was a trendy internet hashtag, ordinary people were putting their actual lives on the line. Back in 1730, in Kehartali village, a local ruler sent soldiers to cut down the community's sacred Khejri trees. A woman named Amrita Devi stepped up, physically hugged a tree, and declared her life was less important than the forest. She was killed on the spot. Over the next few days, 363 Bishnois sacrificed their lives exactly the same way, braving the axes. It was so shocking that the ruler permanently banned logging there. That ultimate sacrifice directly inspired the famous Chipko movement in the early 1970s. The big turning point was in March 1974, when peasant women in Rainy Village stood their ground to block loggers from clear-cutting their traditional forests. And that northern victory spread like wildfire. By September 1983, it inspired folks down in southern India to march into the Kalisay forest and wrap their arms around the trees, launching the Appiko movement, Appiko being the local word for huggin. And you know what? It absolutely worked. This relentless, on-the-ground pressure eventually forced the government's hand. In 1985, they established the National Wastelands Development Board. Their job wasn't just to talk about conservation. Their direct mandate was to physically increase the green cover on degraded lands across the country and write robust policies to stop healthy, fertile land from turning into wasteland in the first place. Finally, Section 4, Nature's Warning Systems. Let's dive into ecological sentinels. So, how do scientists actually ask an ecosystem if it's healthy? Well, you can't just scoop up a vial of water and test it for one single chemical, because natural habitats are these massively complex cocktails. Instead, they use what's called a bioassay. Rather than just relying on standard chemistry, scientists introduce highly sensitive living organisms, like specific insects or fish, into the soil or water samples. By watching exactly how those living things react, scientists can accurately measure the lethal concentration of pollution that is causing real-world mortality in the wild. But we have to be incredibly strategic about which species we monitor and protect, because they have very different jobs. Take Keystone species. These animals are structurally vital to the physical ecosystem. Think of an apex predator like a tiger. The tiger eats the deer. If you lose the deer population explodes. They overgraze the forest, the bugs die, and the whole system completely collapses. The tiger literally holds the food web together. On the flip side, we have flagship species, like the giant panda. Let's be real. It's tough to get public funding to protect a super important, but maybe kind of ugly bug. That's why conservationists use highly appealing, charismatic animals like the panda. They might not be the structural linchpin of their ecosystem, but they are absolute game changers for engendering public sympathy, selling merch, and raising the massive funds required to protect wild habitats. Then we have the indicator species. These are your literal canaries in the coal mine. Back in the day, miners actually brought caged canaries deep underground because the birds' fast metabolisms meant they would succumb to invisible, toxic gases like carbon monoxide way before the humans did, giving the miners an early warning to evacuate. Nature provides these exact same warnings for us globally today. We watch amphibians whose super permeable skin makes them hypersensitive early warners for chemical pollution and climate change. We track ocean birds like the Atlantic puffin to gauge the health of deep-sea fish stocks. And lichens, you know those crusty, flaky things growing on rocks and tree trunks? They are so wildly sensitive to sulfur dioxide that their mere presence or absence is a perfect, living indicator of the local air quality. Ecologists also keep a really close eye on foundation species and umbrella species. Foundation species are exactly what they sound like, the dominant primary producers that literally build the habitat. Think of the massive kelp in kelp forests, or the hard corals building up tropical reefs. Without them, there is no home for anybody else. Umbrella species take a totally different angle. These are animals that need massive, sweeping territories just to survive and hunt.
By fighting the difficult legal and political battles to protect their huge roaming areas, we automatically throw this giant protective umbrella over thousands of smaller plants, insects, and animals that just happen to share that exact same land.
To wrap up this explainer, we've seen just how intimately our personal health is tied to our environment. From the lead on our windowsills to the biomagnification of toxins right up our food chain, we simply cannot separate ourselves from the natural world. And seeing how historical grassroots movements bravely put everything on the line forces us to look in the mirror and ask a pretty tough question. As we continually reshape the Earth's habitats through massive industry and agriculture, what kind of indicator species is humanity becoming? Are we just the toxic pollutant disrupting the complex systems around us? Or can we evolve to be the ultimate umbrella species, fiercely protecting the global community we all rely on? That is a vital question we are all going to have to answer.